Hi, Sujit.
Hi.
Sujit, I think we can start. Or guys, if you have any doubts, then please ask that first. Meanwhile, others are joining. Any of you has any question regarding assignment or the previous sessions or anything? Please go ahead. Okay, Sujit, I think we can start now.
You look like a grasshopper. Sitting in this. All right. So nobody has questions today related to assignment or anything.
Someone was asking me in the Slack channel.
Yeah. Many were. I'm like, they all have, a sort of introduced their discomfort related to the competition data set. That's a basic data set. I can give it to you. If you can't work it out, then I'm afraid.
Ame, Ame, are you here? Ame, are you here? Okay, I think he is not joined.
Yeah.
Okay, start with the today's session.
Okay, so today we will be doing, today is the last lecture, is it? Correct?
Yes, if
Yeah.
the contents in the contents are have been covered, then this is the last session. Yeah.
Content and the word, obviously we can't cover NLP or other stuff because of time constraint, and additionally you guys are not ready for it. That's true. We can also do it like this. You guys can try this to work all these things. What I'm going to tell you, there's not going to be much of a difference. It's just concepts evolving now with the basic fundamental of mathematics and other stuff. So once you are done with all of these things, you can ping me back or ask me a specific question when you're guys trying to work on it. I'll try to reply to your answers or to your questions based on what I've taught and what else I know as well. There can be situations that I don't know, might not be knowing to your answers, but I hardly doubt that. But let's see. So we can look at that. So just to rephrase again, you have looked at the competition data set. You have to train a model on the classification for 1 and 0. I think other people are doing it. And you have to submit that to the PGAC Council on the link that they will be making. And the people who will be making those attempts will only be eligible for the certificate. Others will not. So today you might have received a link in your Slack. Okay.
Today they will receive. They will receive today. I have generated the form where they can upload their codes, but today they will receive after this meeting.
Okay. So, and additionally, you might have received a link in the Slack or Google Collaboratory for today's class. You can open it. You can't edit it, but yes, you can definitely open it. Right. So you can open it and we can walk it through. Additionally, you would like to open your own collaboratory. Firstly, how many of you are aware of collaboratory here? Is there any deadline for uploading the code? Yes, the deadline is this weekend.
Sujit, I was checking that course content. So we have covered deep learning models, all the three models.
No, today we are covering the deep. We have covered theoretically the deep learning model and mathematics behind it. Today we are doing the coding part. That's it.
Okay, and unsupervised learning.
Unsupervised learning we have not done. We have done only supervised learning. We have done KNN and other stuff, which can be used for clustering and other stuff. So it might. So now the things which are getting more trickier, and I was very much afraid that participants which are here either they're not coming or they are not, trying to relate it or work it out. So I can't help it out. And it's anyway, I have gone way too slow to make things as extended as possible.
Yes, we had some sessions over basic mathematics. That's why it took long.
Yeah, and additionally, many students do not come as well. So I'm a bit sad due to that. That I had to conduct those, but still people were not interested. Some of them were only interested. So out of 180, we had just few people who were there to do stuff. So yeah, we have not done unsupervised or I think, but today we are going to do the deep learning, which and other techniques, which will almost cover the lecture for all the supervised classification, which anybody for a beginner. So whatever we have covered till date would be suitable for a beginner to develop any model on any given data set and get a generated classification or regression prediction.
Okay, so let's start, and at the last, we will be coming to the course content. And if something is left, then we will discuss at the last what is
Mhm.
remaining. Okay,
Okay.
okay.
So are you able to see my screen here with the Google Collaboratory?
Yes.
Okay. So how many of you are aware with Google Collaboratory? Have you ever worked with it? So if you have not worked, yes or no? Let's see what I was saying. No, 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 no. Okay. So it's very simple. You will just go to your Gmail, or you can go to your Drive, OneDrive. Sorry, Google Drive, not OneDrive. And then you go on Plus, okay? And here you will be able to find Google Collaboratory. So once you click on that, a new link will appear, and it is like a Jupyter notebook but hosted on the cloud. So you will be using Google's computation and system servers for doing this thing. If you are unable to get it, then you will have to go to your drive and then add maybe an option here, which is plus new, more, connect plus more apps, and then it will open up. And here you will have just you type collaboratory and it will come up, and you just click on install. It will install automatically. Am I clear?
Yes, you can thumbs up if you got the process.
Yeah. You can also just search Google Colab and it will be enough for you. Now I'll just quickly go to your, so whatever I'm going through, you might try to copy it in your own cell and run it. Since it is not going to use your computation or anything, you might not feel any problem. So you see here, so this first thing, as we have done in the Jupyter notebook as well, is called the cell. So once you go in there and you see this button here, it is to run a specific cell. Or we can do the similar way as we used to do in the Jupyter notebook, which is Control plus Enter. Okay, so once you run it, now we're going to work it on the CFAR 10 dataset. It is a very famous dataset in which you have different images of frog, truck, deer, automobile, cat, and other stuff. You have totally 10 different classes with our main classes. So you will have for every classes, you will have several images. So we'll just, what are you going to do here is just going to download this data set. So by dataset.cfar10.download load data, it is going to load the data into train images, train labels, test images, and test labels. Okay, and then you will have train images and test images. You're going to normalize them. So you just, since they are the RGB values and they're the color images, you will just divide them by 255. So you just did train images by 255 and test images by 255. Once you do that, it will start downloading data from the server, and it's done. Okay, so now you have, so now what you want to do is you want to verify how the data set looks at. So you try to plot some images from it. So you want this 25 images and you want to see what is there in the data set. So you just run this part and you see you got different images of ship, cat, truck, frog, bird, and that stuff. Okay, now we talked about convolution layer on that day. All right, we talked about convolution layer and we talked about how it performs the convolution and other stuff, right? So now we have, so everybody is done with these two steps. Okay, one guy is done. Two done. Okay, I'll just connect my surface to it. So by the time if everybody is done to it, we are just going to now, so this is our data set, and what we want from here is just the stuff, which is to create a convolution layer and let it do the feature extraction and other stuff. And so now we are not going to extract any features or anything that we used to do in the machine learning or anything. So what we are going to do here is just going to use it for the conversion. So let me just quickly. Okay, so joined. Okay, so okay. So we learned on that day that for convolution, what we have to do is, if this is your image, so what it will do is it will try to do a filter over it, which is, let's say, of 3 by 3 size, and it is going to move it along the let's say along the columns and then along the rows. So this will be the total dimension of your image. So let's say the image size is 64 by 64. So you will just keep on moving it. So the concepts that we learned on that day was these are the x and y of your image, which is the two different coordinates. And so image representation will always be like this. So x, comma y, comma z. okay, where X is your, let's say, the X and Y are your input image dimension, where Z is your depth, which is, in this case, it would be colors. Okay, so in this case, if you look at these images that we are seeing here, is what we are able to see that in these images we are seeing that image size is 32 by 32, and since it is RGB, it will be by 3. So your input image dimension is 32 by 32 by 3. Okay. Now you create the convolution base. So on that day, we also learned that, so how my whole convolution layers will look like, that this is my input, and then I'll perform a convolution over this thing and create a convolution layers here. And similarly, I'll add another convolution layer, another convolution layer, or needed depending on, and every convolution layer will have one activation function, which is relu or something else, whichever you see it fine. We have learned about relu, we have learned about sigmoid, we have learned about tan-x, we have learned about leaky relu, and many more. Okay, so these all things will be there. Now we have this thing, and then we do the max pooling as well. Max pooling or average pooling. So you will come to know that once you do the max pooling or average pooling, you are actually reducing the dimension of X and Y. So once you do max pooling of, let's say, by 2, you will reduce the size of 54 by 54 to 32 by 32. Okay. So now for that, so we initiated the model by calling model.sequential. So we have, if you look at the libraries that we have imported TensorFlow.keras and dataset, layers, and models. So here we have, from the models, we have called out model.sequential. Okay. So here we are at model.sequential. Then we add layers.con2d 32, 3, and 3 activation relu input shape this thing. Now let's take a look at everything what is written here. So this part is your input shape. Okay. So whatever is input is your this part. Then this is your activation function. Okay. Now this thing is number of filters, and this is size of filters. Okay, so what is happening here is we are using 32 filters of size 3 by 3 by 1, 2, and using the activation relu, and the input shape is given like this. Okay, and then we do the max pooling of 2 by 2. Okay, so this is in the first step, that is what we are doing. So everybody try to type this out in your own notebook. Okay, so after this out, so this is the convolution layer that we are using. Now there is one more thing that I want to bring your attention to, is if I want to calculate the output. Shit is this? Yeah. Okay. No. So if I want to calculate the output of convolution layer, what will my output will be? The formula for calculating the output is W. So this is your input. Okay. So input, whatever your input is, so that will become Wx. Then you will so now you will subtract, since you are using kernel of a specific size, you're going to subtract that kernel because you're reducing by that factor. So minus kernel. The other terms comes up as padding. You add the twice of a padding, what you're going to do, divided by s, and then plus 1. Okay, so this is the formula to calculate it. Now padding is the scenario. Let's say that this was your image. Okay, so this image was of this size 1 2 3 4, 1 2 3 4 5. Okay, so the image was of this thing. Now you wanted to perform a convolution over this thing of 3 by 3. Okay, keeping a stride of 1. Stride means how much it is going to move. So if my stride is 1, it is going to go from here. So it is just going to move one step. Okay, if my stride would be 2, if my stride would be 2, then it would have gone from here. If the stride would have been 3, it is gone from here. So it's like number of columns you're going to leave. Okay, so now once we start that, we see that in the first convolution the filter was applied like this and you calculated the output here. Now you move this whole filter, which is of 3 by 3 size only, to one step. You reached here. Okay, so now your second output is here. Now you took the third one and then you move here, and your third output is here. Okay, so if this was not the case and I was using a stride 2, let's say, okay, so what would have happened then? So if I'm using the stride of 2 and my image was of this size, yeah, so now I'm going to use the stride of 2. So this is my first block that I have considered. Now I can't use it from here. So what I'm going to use? I'm going to use from here. So because my stride is 2, so I start from here. And now you see only 2 blocks are there. I don't have the third block. So what will happen now if I make the padding is equal to true, or I add the padding, then it will add the 0, 0, 0 around the images. Okay, so it will add the 0 around the image so that we don't leave any corner cases. So image would be able to learn from that. So this is the purpose of padding. The purpose of padding is to cover the boundary information of the image as well. Okay. So now if we go by this by the formula that we've learned right now, we have this input shape. Can everyone calculate me the output right now and quickly paste it in the chat? Tell me the output of this layer. What's taking so time? Come on. You guys here are sleeping. No, just tell me the output shape. you are seeing it here from the parameters. I'm asking about the output shape. I'll tell you none. What is none? Don't look at this thing no below right now. Don't be smart. So your output is 30 by 30 by 32. So what is he saying is this thing. So others people, have you tried to do it? Just show me thumbs up who are here. 1, 2, 3. So just please try to do with me. I can understand it is a festive season and you guys might be working as well. So just be with me for the next 20 minutes and then we will be finishing it off straightforward. It's very important for you. So we have 32, that was our input, right? So this is the 132x, right? So it is, you have this thing. So you're going to take the, so consider that this is x, this is y. So you need to calculate for x first, okay? Since both of them are the same size, x and y, your output will be the same. But if they were not the same, then it would be different, right? So you need to calculate for the x and y individually. So here you have 32, and then I said minus the size of the kernel. So the size of the kernel is 3, right? We are using 3 here. So it would be 29. And then plus 2 multiplied by the padding. In our case, it is not there, so it is 0. Divided by stride, and our stride is equal to 1. Since we have not defined anything, it's default 1. Okay, and then plus 1. So if I do this calculation, 32 minus 3, it will be plus 1. So 29 plus 1, 30. Okay, so your this dimension, now the output of this dimension, which was 32 by 32, is now going to reduce to 30 by 30. Now, one of our fellows said that it is 32, that is the filter size is 30. So how come he's saying 30 by 30 by 32? He's saying 30 by 30 by 32 because you have 32 filters here. So that will add to your depth. Okay. So now if you look at it, it is actually, you can see at the stacks of the blocks of the filter of the output, which is 30 by 30 by 32. Okay. So this is what we get as an output. So this is the output of this layer. So the output of this layer is 30 by 30 by 32. Now can somebody tell me the output of this layer? The depth is 32 because we are using 32 filters. So it's like for the first time it will run over the images, it will collect that, and then second filter, then third filter, it is stacking all of the filters on the top of each other. So you will have 32 filters because you have defined it. You could have chosen 16 as well, then it would be 16. If you were to choose 8, then it would be 8. So you're saying it would be 30 by 30 by 64. How? Or did I stop sharing? Sorry. Akanksha Gupta to everyone, 15 by 15 by 32. How, Akanksha? Can you explain? Come on, talk to me, guys. It's boring if you don't speak. Mhm.
So is this sequence? It's getting on top of each other, right?
Yeah.
So the first layer would give me a 30 cross 30 cross 32, and that would be used as the input shape, right?
Mhm.
Or do I start again?
No, you will be used that as it. So it is sequential model. So that is a
And
very good question somebody asked. So it is a sequential model. So this will become your first layer.
right, and then the pooling thing will do something over this 30, right?
Yes.
So I have a 2 cross 2 ka window that works on 30 by 30 ka input shape.
Yeah.
So I have a 30 minus 2 plus I forgot the
Okay, no problem. So if you look at it, this was a very good
yeah.
attempt. So if you have 30 by 30, so max pooling, what it does, as we discussed, so if you have this whole thing, okay, so if you have this whole thing, so what does max pooling do is it will draw a 2 by 2 matrix, right? It will draw a 2 by 2 matrix over your input and take the maximum value from that matrix. Okay, so it will just take one output from here. Okay. Similarly, if you start moving it, that it will take one output from here. Okay. So this is what your max pooling does. If it would be average pooling, then it will take in the average of these values. Okay. So even I wanted you to calculate not using the max pooling, but it's okay if you consider that, no problem. So here we can see the max pooling is 2 by 2. So it is just going to subsample it to the half. Okay, so it was 30 before. So now this model will be just reduced to 15 by 15 because we are, splitting by half, taking 2 by 2 and just selecting one value. So now we have 15 by 15 here. And now, so output of this layer was 30 by 30 by 32. Now output of this layer will be 15 by 15. But, oh, come on, sometime. By 32. Now tell me the output of this layer, please, quickly. Okay, and now you talk to me. So whoever sent me, okay, Akanksha Gupta, talk to me how it is. Come on, we don't have the whole day. My mic is not good. Okay. Somebody else want to take a lead? Soumya, Mr. Bose, would you like to go ahead, please, and talk me? How did you got it? All right, okay. So it will be repeated with the same step that we did before. So we will be doing the same thing. We have the input now for 15. So it will be 15, and then you will be subtracting minus 3. It will be 12, and then plus 1. So that will be 13. Okay. So this is what you're gonna get. And now since you're using 64 filters, so now your output will be this multiplied by your width multiplied by your depth. So the depth will be 64 filters now. You apply the same thing here. So now it will be reduced by the factor of 2 again because you're using max pooling of 2. So now your output would be 8. No, 13 or 6. So 6 by 6 by 64. And so 64 was, so depth doesn't change with this thing. Okay, and then you have the final value, which is here of 64 filters again by 3 by 3. So you will be having 6 minus 3 plus 1. So it will be 4 by 4 into 64. So this is the final output. So everything is getting passed to the activation layer ReLU as well. So if you want to see the features of every output, you can just take out the weights of every model learned and plot it, and you will see that what features did they learn. Okay, so it can be done with any images. So this whole block, you can pick it up. So if you want to have a very cookbook thing for you, so what you can do is you can just change here, just here in your train images and train labels. You just need to replace it with your training images and corresponding to its labels, and you run the same model, you will be able to get an output. Depending, few things are more there to change. Don't worry about it. We'll cover it. So the basic model will remain like this. You can add a model. Sorry, you can add a layer. You can remove a layer. You can do anything with this. If I remove these two layers, it will be just a single, so it will be one layer convolution. Okay. So now we have seen that we have done the convolution here, but we discussed on that day that's only convolution we're going to work, because it's not going to classify. We will require a fully connected network to classify it into different classes we have, and the number of classes that we have is 10, right? So now we are going to see that we have seen the convolution 2D max poly. Okay, somebody asked what is this none. So this none is represent. So whenever we deal with TensorFlow, so there is this thing. So they represent the thing as this thing, which is first is your batch size. Okay, first argument your batch size. Second argument is your image width, height, and depth. Okay. So this is for 3D, sorry, 2D images, okay? Because you will have these two things, okay? But so I'm just giving you an idea. So now if I use a 3D image, okay, a 3D image, then what will happen? You will have image width, height, and real depth and color. Okay, in that case, your input will be 5D. So sometime when you will try to run TensorFlow, it might give you an error by saying that I expected to receive an input of 4D matrix, sorry, or 4D array in case of 2D images, and but got 3D. So in that case, what will happen is actually you're not giving the batch size or something. So batch size, we have talked on that day that how your model trained in a stochastic gradient descent, we give it in a batch. If I have say 1,000, let's say if I have just 100 images for a class, and I want to train them into a batches of 20, then I will have 5 iterations to go. Okay, so it will firstly pick 20 and then other images, then another 20, then another 20, then another 20, and then try to see whole the data set. Okay, so this is how it happens. So now convolution 2D and the max pooling layer 2D, the 3D tensor of the shape, height, width, and channels. The width and the height dimension tend to shrink as you go deeper in the network. The number of output channels for each convolution 2D is controlled by first argument, that is 32 or 64. Typically, as the width and the height shrink, you can afford computationally to add more output channels in each convolution 2D layer. Now, we did cover that day that after this we'll have to have a fully connected layer, a dense layer. So it is represented by the dense layer here. So what you're going to do is you're going to call the flatten. So flatten is going to convert this whole thing, which was of this shape, into a long strip of data. Okay. And then after this, you have a dense layer. So the dense layer will have 64 neurons into it, and then you have the activation ReLU here. Okay, so this is what we have done from here. So it is gone to 64, and after this, we have how many classes? We have 10 classes. So after this, we have a dense layer connecting to the 10 neurons, right? So it has 10 different classes to classify as an output. Okay, so we add this thing, and then it's done. Now add dense layer. It is done. Try to look at my model now. So I'm looking at by calling model the summary. So what are layers are here? So now we have one convolution 2D layer with with 3 by 3. So output shape is this thing. Max pooling 2D, output shape reduced by a factor of 2. Then convolution 2D, another layer which is represented by 2D underscore 1. It is output is 13, 13, 64. Then you add another max pooling, reduced by a factor of 2. So it is 6. Then convolution 2D, and then again you have another of 3 by 3, which give you an output of 4 by 4 by 64, and then you flatten it out, so it will be 1024. So how did 1024 comes up? So if you just so now you do the flattening, so you have 4 by 4 by 64 layers, and then you have total, after flattening you have 1024 parameters. So after flattening, it's converted to 1024, and then you have this dense layer of 64 neurons and then 10 neurons, which is mapping. So it just gets multiplied with each layer to have the parameters coming up. The total trainable parameters here is this much. You can ignore that. As higher the parameters will be, the more time it will take to compute all of them. Okay, so the output vector is 4 by 4 by 64 and vectors of shape 1024 before going through the two dense layers. So now we have model.compile. So here now we are trying to compile our model. We learned about the different optimizers. We learned about different optimizers on that day in the terms of SGDM or GDM or Adam and some others as well. So now here we are using optimizers Adam. So you can also do this thing is whatever term is written here, you can just go on your Google and just write here tensor flow model.compile, and as soon as you do that you will see this model comes up. Okay, so it will give you an argument here. So TensorFlow Keras model, here your arguments are inputs, outputs, and name. Okay, so here you can see that input is your shape, this thing, this is your tensor output, and then model, and then you do call initialize. Yeah, so compile is the method. So you have optimizer here. So you can see the optimizer. So you can give an optimizer. So it's in a string. It will take an input of a string. Similarly, you have the loss, you have the matrix, you have the loss weights, weighted matrix, and other stuff. So this you can do with any of the things that we did before, right? So for example, if I want to understand model dot sequential, this is what we were doing, right? So we go on here to tf.keras or sequential. We are able to see the sequential here. Then we can add. So here you can see model.add keras.layers dense layer. So you're just adding with the dense layer. Then you can also look at TensorFlow conv 2D. So now you see tf.keras.layers of conv 2D, and then similarly once you go here you will be to see that the output is, sorry, the input is like filters, filter size or kernel size, then your stride, then your padding, data format, dilation rate, groups or activation. You can read about all of them if it is required. If you think you are going to use it, the description is also here. Okay, now let's coming back to this thing. So our optimizer is Adam. The loss that we are going to use is sparse categorical cross entropy, and the matrix is accuracy. So these are all the parameters that we have from the model or compile. And then we are going, so history is to log all the values of your losses in the terms of your accuracy and your dropping loss and other stuff, so that you can make a plot later on. Whichever paper you try to publish with machine learning or something, they will ask for your loss plot and every other stuff, because it is going to give them a better understanding of how it is happening. So optimizers.adam, then you have loss.sparse category cross entropy, and then you start training them. So as soon as it starts training, you can see that for epoch 1 out of 20, so it is going to run for 20 epochs. It is going to start training it and so you see it is training them now. So your first time your loss is 1.522, accuracy is 0.44, validation loss is 1.25, validation accuracy is something else, 0.54. This loss should go down. Okay, your objective is to take this loss, which you're seeing here. If you can see my cursor, this loss should go down. This accuracy should go up. Validation loss should also go on, but as soon as the validation loss starts shooting up, you'll have to stop the model from training. Otherwise, your model is getting overtrained. You see, it is dropping as well, and it is dropping as well. Let's observe it for a few minutes because we have just 20 epochs to train. Shouldn't it be 100 C20 iterations? Never mind. What do you mean by that? Oh, number of iterations would be based on the epochs and the multiplication of the batch. How can we install and use it in Jupyter? Wow. You will have to install TensorFlow into your Anaconda prompt by conda install TensorFlow, I think. And once you have that in your environment, you can run the same thing into your own Jupyter notebook as well. But since I expect not every one of you to have your own GPU, I can do it on my uh, I can do it on my computer because I have GPU, RTX 2080 Ti. But if you guys don't have the GPU, it will be burden on your computer. So you can use free resources like Google Colab. It doesn't cost you any money. So you can train any of your model, and it uses the backend as GPU. You can check your runtime and other stuff to see if it is using the GPU or not. So I can check right now. I don't think it was using my GPU. So you can change runtime. Hardware accelerator is GPU, and you can set it to TPU or GPU, whatever you feel like. Now you see this whole comes up. So now your loss has reduced continuously, but your validation loss has shot up. So we could have stopped it somewhere here, for the training, rather than going all deep. So now once we looked at it, now I want to look at, so I can't go through every single value. So I'll try to generate a plot of the loss and try to see if I was correct. So if you look at this thing, so you see the accuracy and the validation accuracy. So validation accuracy somewhere maintained here, and the accuracy is here. We can also do that for the loss as well. So instead of accuracy, you can just get it for the validation loss, okay, and the training loss. And once I do it, you see this. So this is the concept of model overfitting. Is my model is not trying to try to learn anything or something. Okay, you can change the x-axis and y-axis. I'm going to change that. You can see this. Now, if you play with the optimizer, you can probably make it much better. Let's say I use SGDM. And you train it for more period of time, it might improve as well. Adam should work in this case, but if I change few of the things, maybe.
I'm a little confused here. So my validation loss shot up after the 17th epoch out of 20. So basically, what are we supposed to do in such a situation?
It means that your model has overfit. So that's why you start to change your parameters and you try to look where it doesn't shoot up.
Okay, but it's not like I stop after the 17th epoch, right? That's not the way to go.
Or if you stop it after the 17th epoch, you can stop it. Yeah, I can stop it any time. It will stop the execution, but your
Right.
model will not be able to save it or something.
Okay.
So, for example, if I start with, let's say, I change some of the parameters of the dense layer, now you see the values are changing. Okay, so your accuracy is improving, but you actually are more concerned about the validation accuracy, not in the training accuracy. So you're looking at, you see the difference, and the validation loss is not coming down. So you can play with many of the parameters of the atom, for example, the momentum or the other terms that we have considered, and it will be able to show the different scenario here. So, for example, so here you can change your model parameters. For example, you are 32 by 3 by 3. You can change it of the size filter. Let's say the filter size be 32, 3, but you don't need this convolution. Maybe there is nothing much to learn from here. So you just stop it right here, and then you again learn the, retrain the model. So you will be able to stop it, and then you will be able to play with your around in order to see how. So you basically you can tweak something in the model, and you will be able to improve the classification performance. The important parameters are the filter size, number of filters. If you are using too much filters, it can be a problem that your model is trying to learn too much information from the given information when there is none. So in that case, you should reduce the number of filters. Okay. For example, we can see something very fastly is, let's say, is that we have this scenario, right? We have 32, and then I reduce it to not 64, but 16, okay? And then I run this thing, and then I run this thing. So I have this thing only. Now I add the dense layer, and then one summary. And now I try to train. So you will be able to see that there will be a different change. So loss start with 1.4. It's different from this other scenario. Your validation loss is going down. This loss is trying to go down as well. So this is what we have to be keep. Your major concern should be, actually, if I tell you from the machine learning point of view, is your this loss and this loss. You have to just keep a track of both the things. So it should be this scenario. It should go down like this for the this loss, and for this loss it should be also, maybe it starts higher than this thing, but it should go closer to this thing and then shoot up. So you have to, so whatever epoch this is, you have to stop it right here. So if this can be optimum accuracy a model will be able to give. Okay, so for example, if you, in order to look for this thing, so you see validation loss is again rising up after 0.97, so no point of training. You can change your optimizer and it would do the job as well. So you just I think it's GDM and then gradient and no SGD and then momentum. Sorry. So in SGDM, I think you have to use the gradient SGD, and then you have to tell the momentum itself. So you have Eta delta Adam SGD. Yeah, I was correct. So you have gradient descent with momentum optimizer. So you can give SGD, and then you try to give the momentum as well, and in order to change it or play around with it to go ahead. So you have learning rate, momentum, Nestrov, and other stuff. Okay. So this is one thing. Additionally, there was one of my paper which I published. So I'll just show you very quickly. There it is. So in this paper, I also designed my own architecture for this. This was signals, right? So these are the brain signals, and then child. So this is the architecture that I designed, right? So what I did was I have this whole thing, which is your convolution layers, different. And then I used multiple convolution layer into a single block. So not this one exactly, I think, sorry, it should be down below. Architecture 2, yeah, for transfer learning. So this individual, yeah. So this individual 1 mega block had the capacity to increase itself from 1 convolution layers to 5 convolution layers, right? So it can extend itself based on the noise in the data and other parameters to find the maximum accuracy and optimum layers in the model. Okay, so you can see these thing is, in this case it is going into those things, and then similarly you have the same thing, which is output, the softmax and classification. There was only 2 classes in this thing, so that was the case. Now since it was just a signal, obviously we got that, and for this I used Bayesian hyperparameter optimization. Now, okay, so this is what we looked at, right? So this is the overfitting issue that you're encountering, okay, where your loss is going down, but your validation loss is shorter. So we can change the parameter in order to get to the graph where I told you that it should be looking like that. Okay, so this is what we have here. So you got the test accuracy, and your test accuracy is 70%, and then you just are randomly plotting an image. I think I messed something. Yeah. So now it is randomly plotting an image, and it's a true level. So class name is shift, and it is shift. You're trying to get the shape of the image. Shape of the image is the same as we got, 32 by 32 by 3. We can reshape shape of an image by 1, 32, 32 by 3. So it will be 1 can be 10 as the batch size here. So when you have this batch size, then you can model a predicted image. So once you feed it, you will get a prediction here by multiplied by that different weights. So you don't need to worry about all these things actually. So this is the base model that you will be doing with any of your input data. Okay, I'll just quickly go ahead with the same another type of the model here, which is the LSTM model. Okay, so LSTM is the long short-term memory networks, and in this case we use it for basically signals. Okay, or signals are something which is one-dimensional. Okay, so LSTM will be used for time dependency, right? If there is some factor of time which is changing, then we can use LSTM, and it is supposed to work much better in those scenarios. For example, your stock predictions, they're dependent on time. Your any signals, they are respect to the time, right? Or some other data set which is a dependent of time and it has changed by time, we can use the LSTM models to work it much better. So in this case as well, you do nothing, you just import the keras.layers.lstm. Okay, and then you again, so it's a simple data set that you're trying to load, and so we just come here. So there is some sequencing and other stuff, but what we want to just look at here is this thing. So you have model, you're trying to embed the top words of vector length, input length, but LSTM is here. So you're trying to add an LSTM layer with 100 cells. I have not taught you LSTM, so it would be difficult for me to, where is this notebook? This notebook is with me. Okay, I've not shared it. Oh. So on your Slack now. So now you have this model. So LSTM has 100 nodes. right? So it is trying to run 100 cells and it is trying to learn from those 100 cells. If you are using by LSTM, it would be, you will be 100 cells, but the output which we'll be seeing here will be 200. Okay. And then this is the same way we try to train the model where nothing we are doing else, which is we are all adding the model. So you always call model sequential, you add, then you add an LSTM layer, then you map it to the one dense layer, and then you model summary. So in this case, if I have not taught you, but I'll give you a very basic scenario of this thing. So in this case, in the previous CNN, we were able to see that when your dense layer is like this, and you try to map it to two of them, all of them gets mapped to two of them for a specific way, right? This is the case of this thing. But in the case of LSTM, it's not like that. So your every hidden state or the new concept will pop up. So how can I say this? Like we can say that every state which is time dependent factor, so let's say at time t1, it will be mapped to an output 1 at that same time, y1. Okay. Similarly, t2 will be for the y2. So I can give you maybe a notebook of the signals in the same scenario. I have that for one of the another paper that I published where I made the first ever EEG GAN. So more MIEEG GAN. Nobody did it before me. It was a completely new architecture where I designed it to generate artificial brain signals. So in that case, I tweaked with the bio-LSTM models and other stuff. And if you anybody is more interested or something, I can give you something on that. Okay. Now today we are out of time, so we might yeah, so this is it. You guys can go ahead and try. And with this whole notebook thing, you have all the view. I'm not going to give you the notebook. I want you to create your own this time, to type it out and try this thing. Right? So today then I'll end it right here with your efficiency to try these models and see how it goes up and try and then see where you're facing issue, and then obviously I'm here to sort this out. So I'm going to take maybe one more session, which is, I don't know, I know it's Diwali, so you guys can let me know, and if you guys are able to do it, and then we can have one more session on this one whenever you feel like. So PGNC.
Yes, I would like to discuss a little bit about the course content. I mean, whatever has been covered and what is remaining.
All right, go ahead.
So, I think you might have that file, right? That Word document file. Or
Yeah,
should I share my screen?
I'm just opening it on Slack itself.
Okay.
Yeah, I have the content. Go ahead.
So basic Python we have done.
Yeah, we have done basic Python.
Visualization, this also we have done. Box
Yes.
plot, Gaussian plots, etc.
Yes.
Dimensionality, PCA, TSNE, SVD, these all done.
Yes.
NN and this
Done.
regression, SVM, decision trees, and I don't know about ensemble models, DT. That has been done or not?
Decision trees, yeah. So ensembling is I have taught them. So it's like multiple models building together, random forest on the sub with the alpha, theoretically, yes.
Okay, and this NN, CNN, and LSTM has been done.
CNN, LSTM right now done.
Yeah.
NN theory done, CNN practical, and LSTM practical both are with them. They have to try it out.
Unsupervised learning is remaining, right?
Yeah.
And this whole NLP section is remaining.
NLP will not be, I don't find it, yeah, NLP full section is remaining, and I'm not confident on, not confident, or like you can say that, if you want me to cover, I can cover it in maybe one session or something like that, but no point, because the people who are here are not familiar with simple data set. So maybe if you think, maybe let the participants try, and if they feel tomorrow or something like that, not tomorrow, I mean like in coming months when they have tried all these things and they see a use, because they're going to forget in 5 days if they're not going to try it out. So maybe throwing everything, this whatever the syllabus course content that you have given to us, it's 2 semester course contents
Yeah,
technically.
yeah. Many of other students have told me who are, I mean, familiar with machine learning. They have told me that you are covering a lot of things. But anyway, I won't disappoint you, all the participants. So our Slack channel will be active, and I mean, you can say like after 1 week or so, if candidates are able to, I mean, they are requiring about this, they are asking, then we can have a session on this, and within in that session I think so it can explain whatever is remaining if they are able to cover all the things which have been covered so far.
Yeah, I would like to take one more session, which is just on the doubts, which is LSTM and CNN we did today. Go ahead and try with your own data set or something like that with your own images. Come back, maybe someday, I don't know, post Diwali. I don't know how your curriculum is working right now, post Diwali, or if you guys in college, come up and then we can talk throughout in this notebook and see if something is missing, which I feel don't. Uh, then we can go
So
ahead. It's for my own satisfaction, actually, not your satisfaction. It's my own satisfaction that I know that I have covered it and you have understood it.
okay, so guys, don't be disappointed. For now, even if you have any questions specifically from NLP, then you can post there and TH or speaker will respond you, but as a whole session we will think of after some time.
See, obviously, I'm like NLP. You can keep it separate. I will tell you one basic thing. I don't know if anybody will be disappointed in NLP here because the people were not understood. You know, they did not knew this thing, which is the basic fundamentals of neural network or something. So I don't know that they must be knowing NLP. It's impossible, and actually, like it's out of bounds. You
No,
don't
like
know about neural networks, and
someone from group A may have such kind of problem,
so
but
only two
because they
or
might be
three
knowing.
students. So only 2 or 3 students. So why not you post if you have done work on queries? So can I reach out to you sometimes? I'm trying to get some perspective or research from my perspective, discuss back or whatever. Yeah, no problem. So you can reach out to me, drop me on Slack. I will try to find my time and talk or help you out in building your models or see a possibility where you can, if you have PhDs, I'll help you out in getting a publication probably or master's even. Bachelors, don't bother about it. Or you can ask me questions, bachelors as well, from different domain. I can help you out. Other people as well, you can reach out to me. And if you have any specific queries, something, I'll try to look into this and try to help you out to solve those queries. Uh, Probably we'll try to do it over the weekends because that is the only time that I get. But over the weeks as well, so we will have to do it as in the night for you guys, which will post evening because my morning time is very busy.
And bachelor guys, don't take it as other ways. Bachelor means, I mean, your expertise in this field, not the degree level.
Yeah.
I mean, yeah. So formally, I think we are done with this series. I mean,
Yeah, we are done with this series
yeah.
finally. I hope you guys now at least have an idea of how to build a model. That was the objective of the series. I know in the selection of the students, it happened that they were able to mix out the students who knew the fundamentals and not knew the fundamentals. But I hope for the people who did not know the fundamentals were able to understand the fundamentals and try it out actually. So I think you can build any model for classification now on any data set that I'm sure of. If you have attended the whole series, you have the scripts and everything. So you just need to, then don't be lazy in just changing the data set with your own data set file name and running the whole model, getting the output. Try to do some work, but it is out there. And you can reach out to me or Gaurav or any other TAs anytime you feel like.
Yes, however, this Slack channel will be open, and if it is going to close, then well before you will be informed that we are going to close this channel. But for now, it is open, so you can put your queries always. I think TA
Yeah,
will
you
also
can
feel
you can
happy.
keep it open. You can keep it open as you have SIGML channel as well of IIT Kanpur still keeps on running. So you can
Yes.
keep it open. And additionally, yeah, I don't know if you guys are aware of this thing. I know you guys are from IIT Kanpur, but I don't know if you're aware of your own college. But you have your own college group, SIGML, and they run a Slack channel. I think fortnightly they conduct a seminar, a discussion, I think around 5 o'clock in the evening on Fridays. And they discuss any publication which is there in NeurIPS or in ICML, a paper that they have read, and they found it useful, and they try to explain the concept of the paper to everyone who is present there. And you can ask many questions. But if you don't know the basics, don't go there.
Of course.
Because they're not going to cover the basics at all. Like, if you ask the questions which is very basic, they'll say like, who let you in? So you can go out there if you have some fundamentals. So you have specific queries, no? You can go out and meet people who are working in this domain. There are a few there will be final year bachelor students as well as master students who will be doing the presentations and other stuff. So you can try that out as well. That would be useful for you. Networking, probably. But looking at your strengths today and the beginning of the class, I have not so high hopes that you're going to bang that door for your help. But anyway.
Yeah, I hope so.
But do try to submit the assignment. You are not getting a certificate without that. I know the tendency of the students, specifically bachelors, getting some letter of recommendation. The certificates is what we are only cared about. So if you're not submitting the assignment or analysis, then you're not getting it. Alternatively, I will also release a script related to that only, which will give you a very basic idea of how different models are there, what sort of outlier detection we did, what sort of modification I have done. So I will also release one of the solution script for the people who have not been able to understand it.
Okay, so I think we are done. If you guys have any queries, something you want to ask from the whole series, then please go ahead.
You can ask me anything. If you have any suggestion that you want that should be considered, please, this is the time. After this call is disconnected, I'll be disconnected.
Probably, yeah, guys.
Are you able to anticipate what changes would occur when you change a parameter? Does it like go all over the place?
Sometimes, yeah, you can. That is again, but actually, it is bit mathematical as well as it comes to the experience. It's like when you train multiple models now, so it will happen that you need to look at some of the parameters changing. You will be able to guess that you should change the parameter towards downwards or increase it in order to make it, to the
But that's
optimum.
still trial and error. It's still trial and error. I mean,
yeah,
so
it
there's
is
this
one method.
So there's this idea, and I don't know. I'm from a background in physics, so a small change should produce a small change in your output. So does that work in this case? If I make a small change to my input, does it lead to a small change in my output?
Okay. So physics is very much open, it's natural science. It's
Yeah.
based on fundamental principles and other stuff. It is very much open. I wish deep learning was that open and people will not call it a black box. But yes, some change will lead to some change. But I can't say that some change will result in what. It can go haywire as well as it will give you an idea. But no, if you read my papers, in there I have discussed about Bayesian hyperparameter optimization. And so this is a parameter technique that I have used in order to find out the optimum parameters by defining different 30 objective functions. So I defined 30 objective functions based on my learning rate, number of convolution layers, momentum, and regularization parameter. Based on that, I defined those things, and then I trained the model. So out of the 30 objective functions, it tried to minimize it, and then it chose one of them which was the best in it. Okay, one recommendation: as we created group A and B during the course of this course, it should be created A, B in initio, and contents can be modulated accordingly. I think that would help both the groups and then stuff. MA has been I think what you're trying to say is what I'm thinking, but I'm unable to comprehend it. But yeah, so I don't know, the session is ended, no? So now what you're suggesting to divide it in A and B, like Now I think A and B should be together. If B has a
It would help the next batches at least.
Oh, next batches. Okay. Okay. So tell me, were you profitable from it or not? So you were in A or B?
I'm in a big time B.
You're a big time B. So were you able
I
to
had
understand
yeah.
so were you able to understand the
So to be
model?
very honest, I got a little hang of it.
Huh?
I'm not able to comprehend 100% of it naturally, but what I can think that as far as machine learning is concerned, around 60-70% I'm able to comprehend now. The
Okay.
rest of it I need to work upon it.
Yeah. That's great. Which domain are you from? Bachelor's, master's, science, arts, commerce?
I'm a MTech student, electrical department.
Oh, okay. You are, come on,
SPCom.
yeah, so you should be able to understand this. I'm like, not much of a difference. Anybody else here? So let's once talk. I have not talked to any one of you, so why not go ahead? Sambit Bahera. I was about to call him Sambit Patra, but I don't know why.